explore electronics. In the previous video, we have already covered the concept. They are true and false in C, selection statements, and iteration statements. So, if you have not watched those yet, please make sure you go and watch them first and continue with this video. So, you will get a continuation. So, in today's video, we are going to cover another half of the chapter 2 of module 2, that is jump statements, expression statements, and block statements. Let's get started. Make sure you have your pen and notebook ready. Let's get started with the first concept, that is jump statements. See as four statements that perform an unconditional branch. They are return, go to, break, and continue. You can use the break and continue statements in conjunction with any of the loop statement and can also use break with switch. This is about jump statements. Now let us see one by one with a program example. And the first one is the return statement. Here it is used to send control back from a function to the point where it was called. It is called a jump statement because it makes the program jump back to the calling place. A return statement may or may not have a value. If the function has a non-valid return type, then a value must be returned using the return statement. The value returned after a return becomes the result of that function. That's why the return 0 means like that we will write at last of the program, means last line of the program. So that is called as result of the function. Here it is an example. Int add int a comma int b. Here open braces and return a plus b. Means here we are giving a input, that is two values, and returning a value, that is addition of two, that is a plus b. If the function has a void return type, it cannot return any value, as void is nothing but a empty. It does not have anything. So void means it does not return any value. In the void function, return can be used to end the function early, but it should not return a value. In that situation, we will use a void function. Where we will use void function? Where the function has to end early and it should not return any value. During that situation, we will use void function. In C89 version, non-void function could have a return statement without a value, but it would return a garbage value, means which is undefined. In C99 and C++, every non-void function must return a value, otherwise it causes an error. You can use more than one return statement inside a function. Okay, then inside a particular function, you can use one or more return statement. As the first return is executed, the function stops running. The closing brace of a function also acts like a return statement. If a non-valid function ends without returning a value, then that return value is called as undefined. It is always a good programming practice to return a proper value from a non-void function. That's a good practice while writing a program. Now, the general form of return statement is return expression. Sorry, I should have put it on the next line, but write it down. This is a syntax, means return and expression. The expression is only if the function returns a value during that time we will use an expression. If not, return is enough. For void function, I'll repeat once again. For void function, return is enough. But if you want to return any kind of value, on that time you have to use this form, that is return expression. Here also you can see return expression. Here a plus b is called as expression. I will mention it as e. It is called as expression. We are returning expression output value. Okay, on that time we will use this expression, and when we want void function, for void function we will use return function. Next is the Goto statement. Since C has rich set of control structure and additional control using break and continue, there is little need for Goto. Most programmers' chief concern about Goto is tendency to render programs unreadable. Means it is difficult to read. Although Goto statement fell out of favor some years ago, it is occasionally as its uses. Means uh, frequently we won't use Goto statement. In rare cases or exceptional cases, we will use the Goto statement. Okay, as it makes the program unreadable, means difficult to read, we use Goto statement much lesser. While there are no programming situations that require Goto, it is a convenience if we use wisely and can be benefit in a narrow set of programming situations, such as like jumping out of set of deeply nested loops. During that time, the Goto statement will be used. And the Goto is not used in this book. In this book, outside of this section, okay, the Goto statement requires a label for operation. A is a valid identifier followed by a colon. Here see, go to the syntax. In this paragraph, they are explaining about syntax. As it was like short, I have pasted the textbook content itself. Here, the paragraph is telling about the syntax of goto statement. Here, goto is mentioned and next it is followed by label. Where label is any valid label either before or after goto. For example, you could create a loop from 1 to 100 using goto and a label. Here we have declared x is equal to 1 and it is loop 1. X plus plus, if x is less than or equal to 100, then again go to loop 1. Okay, this is a program example for goto statement. And the next statement is the break statement. Here, break statement has two uses. Here you can use it to terminate a case or in the switch statement. In the previous video, I have explained a switch statement. In that case, you will be seeing that after each case, break will be mentioned. Then, when the break statement is encountered inside the loop is immediately terminated and program control resumes at the next statement following the loop. Here is an example. Hash include int and here for loop if t is equal to 10 means repeatedly the loop will be running. When this condition satisfied, it stops because here break is mentioned. Here it prints the number 0 through 10 on the screen. Then the loop terminates because break causes immediate exit from the loop, overriding the conditional test 10 less than 100. Here, programmers often use the break statement in loop in which a special condition can cause immediate termination. The kp hit function returns 0 if you do not press a key. Otherwise, it returns a non-zero value. Because of the wide function differences between computing environment, standard C does not define this function, but you will almost certainly have it. A break causes, this is not much important point, a break causes an exit from only the innermost loop, means in which code blocks, means this is considered as one code block. Where you have mentioned here, suppose if I have mentioned here break means it exists only from the inner block. Here I have another code block means the remaining is continued. Only it exists from the innermost loop. And a break is used in switch statement will affect only that switch and it does not affect any switch happen to be in. Okay, within which switch statement we are using break matters. The next is exit function. Here it is used to immediately terminate the entire program. Notice in the line, entire program. And it is not a program control statement, but it is a library function from standard library.h. When exit is called, the program stops running at once and control is returned to the operating system. It works like breaking out of the entire program, not just from loop or a function, whole program. If it is a many lines, like for example 800 lines also, if exit is mentioned, then it terminates the entire program, not just from the loop or function. The general form of function is void exit int return code. It is a syntax of exit function, and the value of return code is sent to the operating system or calling process. Usually 0 indicates normal program termination, non-zero value indicates abnormal termination or error. In a simple way to say, unexpected. Unexpectedly, if the program gets terminated, during that time it's a non-zero value. You can also use predefined macros such as exit success for normal termination, and for abnormal we will use this. And the header file required for this function is standard library.h. If you write this syntax line in a code, and if you forget to mention the header file starting, then you will get a compiler error. Next, programmers use exit when an important condition for program execution is not met. To stop the program safely, exit function is used in general way. Here is an example. Here the program will be executed. When it comes to here, exit 1, then terminates program if graphics. Here, because we have written exit inside under if loop. So, if graphics means, then the program gets terminated. Here you can see in this example, the function virtual graphics checks if a special graphics adapter is available. If not present, then it returns false and the program terminates immediately. That's what here it mentioned. Exact. If it is present, the program continues normally with a play function. Means it continues from here. That's about the exit function. And the next statement is continue statement. It works somewhat like break statement. Instead of forcing termination, it continue forces the next iteration of the loop takes place, skipping any code in between. For the for loop, continue causes an increment and then conditional test proportion of this loop to execute. For this, while and do while loops, program control passes to the conditional test. For example, the following program counts the number of spaces contained in the string entered by the user. The code is in next slide. That is, this is the code. Here, counting space. Here you declare and printf enter a string gets string. Here we want to count. Here, each character is tested to see if it is a space. If it is not, then the continuous statement forces the for to iterate again. If it is not a space, then it forces again to continue. Begin from the first. No, if the character is a space, then space is incremented. See here. Okay, let me erase this. Here, if the character it is a space, then space is incremented. That is space plus plus. This is an example program for continuous statement. Next statement is expression statements. Here, remember, it is simply a valid expression followed by a semicolon. That is called expression statements. For example, function. Here it is a function call. A is equal to B plus C. Here it is an assignment statement. Here this is called as an expression because addition, it is doing a function of addition. Here it is a valid but a strange statement, right? B, a value, plus we are adding with a function, but it is valid. Or else empty statement, only semicolon. The first expression statement executes a function call, and the second is an assignment, and third is an expression through strange is still evaluated by the compiler because function may perform some necessary task. Means this function may call any other function. The final example shows that a statement can be empty, sometimes even null. The null, empty, void the meaning remains same for these three words, but we will use different context. That's it. And the last statement is block statements. Here it is treated as unit. The statements that make up a block are logically bound together. Block statements are also called as compound statement. A block is begun with open flower braces and terminated by its matching closing braces. Programmers use block statement most commonly to create a multi-statement target for some other statement, such as if. However, you may place a block statement anywhere you would put an any other statement. For example, this is perfectly valid although unusual C code. Right? Here you can see a statement, a block statement, one block and four block. A freestanding block statement. Again in okay, this is called as block statement. That's all for today's concept. I hope you have enjoyed the class and noted down all the important points. If you found this video helpful, don't forget to like, share, and subscribe to Explore Electronics for more simple and exam focused explanation. See you in the next video. Keep learning and keep exploring. See you in the module 3. Bye bye.